Ladies and gentlemen, we are meeting today with a new video of the Engineering in Amharic YouTube channel series.
STAAD-Pro Getting Started in Tutorials Introduction. About STAAD-Pro. About STAAD-Pro Documentation. 1. Getting Started. 2. Tutorials. 3. Frequently performed tasks. Introduction. STAAD-Pro is a general-purpose program for performing the analysis and design of a wide variety of types of structures. The basic 3 activities which are to be carried out to achieve that goal: model generation, B, the calculations to obtain the analytical results, C, result verification, were all facilitated by tools contained in the program's graphical environment. This manual contains 3 sample tutorials which guide you through the steps required to create, analyze, process, and generate reports for each example. The first of those tutorials demonstrates these processes using a simple 2-dimensional steel portal frame. It is a good starting point for learning the program. If you are unfamiliar with STAAD-Pro, you will greatly benefit by going through this tutorial first. For the second tutorial, we have chosen a reinforced concrete frame. We generate the model, perform the analysis, and design the concrete beams and columns. It contains extensive details on the various facilities available for visualization and verification of results. The modeling and analysis of a slab is demonstrated in the third tutorial. Slabs, and other surface entities like walls are modeled using plate elements. Large surface entities may have to be defined using several elements, and this sometimes requires a tool called a mesh generator. This tutorial shows the simple techniques as well as the mesh generation method for generating the finite element model of the slab. It also explains the methods by which one can check the results for plate elements. About STAAD-Pro. STAAD-Pro is a general-purpose structural analysis and design program with applications primarily in the building industry, commercial buildings, bridges and highway structures, industrial structures, chemical plant structures, dams, retaining walls, turbine foundations, culverts, and other embedded structures, etc. The program hence consists of the following facilities to enable this task: graphical model generation utilities as well as text editor-based commands for creating the mathematical model. Beam and column members are represented using lines. Walls, slabs and panel type entities are represented using triangular and quadrilateral finite elements. Solid blocks are represented using brick elements. These utilities allow you to create the geometry, assign properties, orient cross-sections as desired, assign materials like steel, concrete, timber, aluminum, specify supports, apply loads explicitly as well as have the program generate loads, design parameters, etc. Analysis engines for performing linear elastic and p-delta analysis, finite element analysis, frequency extraction, and dynamic response spectrum, time history, steady state, etc. Design engines for code checking and optimization of steel, aluminum and timber members. Reinforcement calculations for concrete beams, columns, slabs and shear walls. Design of shear and moment connections for steel members. Result viewing, result verification and report generation tools for examining displacement diagrams, bending moment and shear force diagrams, beam, plate and solid stress contours, etc. Peripheral tools for activities like import and export of data from and to other widely accepted formats, links with other popular softwares for niche areas like reinforced and pre-stressed concrete slab design, footing design, steel connection design, etc. A library of exposed functions called OpenSTAAD, which allows you to access STAAD-Pro's internal functions and routines as well as its graphical commands to tap into STAAD's database and link input and output data to third-party software written using languages like C, C++, VB, VBA, Fortran, Java, Delphi, etc. Thus, OpenSTAAD can be used to link in-house or third-party applications with STAAD-Pro. About STAAD-Pro documentation. The documentation for STAAD-Pro consists of a set of manuals as described below. These manuals are normally provided only in the electronic format, with perhaps some exceptions such as the Getting Started manual, which may be supplied as a printed book to first-time and new version buyers. All the manuals can be accessed from the help facilities of STAAD-Pro. If you wish to obtain a printed copy of the manuals, these may be ordered through the docs.bentley.com website. Bentley includes the manuals in the PDF format at no cost for those who wish to print them on their own.
Getting started and tutorials. This manual contains information on the contents of the STAAD-Pro package, computer system requirements, installation process, copy protection issues, and a description on how to run the programs in the package. Tutorials that provide detailed and step-by-step explanation on using the programs are also provided. Examples manual. This book offers examples of various problems that can be solved using the STAAD engine. The examples represent various structural analyses and design problems commonly encountered by structural engineers. Graphical environment. This document contains a detailed description of the graphical user interface, GUI, of STAAD-Pro. The topics covered include model generation, structural analysis and design, result verification, and report generation. Technical Reference Manual. This manual deals with the theory behind the engineering calculations made by the STAAD engine. It also includes an explanation of the commands available in the STAAD command file. International Design Codes. This document contains information on the various concrete, steel, and aluminum design codes of several countries that are implemented in STAAD. The documentation for the STAAD-Pro extension components is available separately. Le STAAD-Pro Ekasitanashini Eka, Tosi, Sedochi Betanith Yijinyalu. Section 2 Tutorials. Tutorial 1 Steel Portal Frame. Tutorial 2 Reinforced Concrete Frame. Tutorial 3 Two-Way Concrete Slab. Tutorial 1 Steel Portal Frame. This chapter provides a step-by-step tutorial for creating a 2D portal frame using STAAD-Pro. This tutorial covers the following topics. 1.1 Methods of creating the model. 1.2 Description of the tutorial problem. 1.3 Starting the program. 1.4 Creating a new structure. 1.5 Creating the model using the graphical user interface. 1.6 Viewing the input command file. 1.7 Creating the model using the command file. 1.8 Performing analysis, design. 1.9 Viewing the output file. 1.10 Post-processing. Thank you for watching.